All right, guys, so I'm going to break down this particular question, which often comes up in mocks. It's one that was in the exams a couple of years ago, and it seems to cause a lot of issues for students in understanding why they've got this answer wrong or not being able to tackle it. So, with that in mind, I want to just draw your attention to the question and then I'm going to break it down. So, programmer has written an algorithm to output a series of number, and the algorithm is below. So we know that we've got a for loop here, which says for k 1 to 3. So to break this down, my first line basically says repeat 3 times. And what I'm repeating is anything indented. Okay. And I'm just going to break this one just get rid of this bit for a second. Then my next bit here, my next line, it says for p 1 to 5. So this says repeat 5 times. Okay. And anything indented under here is what I will be repeating. Then once this inner loop has been repeated, it's going to be next p, next k, which basically this next p and next k for those for those that have spent a little bit more time with, say, maybe languages like Python, it just basically means that as you come out of this first sort of set of code, go back and repeat the next p until you're done, and next k. So you can almost just kind of ignore those just for a second to help with your understanding, and just see here that we have an indent. We've got a for loop, sorry, and we've got a nested for loop. So we have a loop inside of a loop. So with that in mind, the question here is give the first 3 numbers that will be printed by this algorithm. Now think about the way that this code works, and the way we can do that is we're going to draw a really simple truth table. And essentially, I want to think about what the value of k is and what the value of p is at every turn. Okay. So the first time, and we're just going to kind of look up to 5 here. The first time that I go through this sequence, what happens? So it says for k 1 to 3, repeat the code beneath. And I come here, and currently that means that k must be equal to 1. Okay. So I'm going to put this in here. So k is equal to 1. And then for p 1 to 5, repeat here. So let's just focus on the fact that p is 1. Okay. And so at this point, it says print k plus p. So I'm not doing anything to k and p at this point. I'm just printing the numbers added together. And so that is 2. Now, I cannot exit and come back up to this k loop because I haven't finished all of my inner loops. And that's only when I've done all 5 iterations here will I come back up and I will say, okay, do you need me to run again? Yes. So right now I'm actually just staying within this loop, which means that k is still equal to 1, but this time the loop's going to run a second time, but p is now equal to 2. And so the answer here is going to be 3. Again, I'm still not finished with my inner loop, so I'm going to come along here and I'm going to increase k is still 1, but p this time on the third time round is now equal to 3. And so the next number is going to be 4. The fourth time round, k is equal to 1, p is equal now to 4. And so we'll just kind of keep jotting these numbers down. And then I'm going to come up here in case, it's going to be equal to 6, or the output. Now, with that in mind, what would happen now, and I know this isn't in the question, but I think it's good for people to understand. What will happen now is that now that I've done all 5 loops, on the first iteration of this loop, I still have 2 iterations to go. So if I come here the second time round, so let's just say that this is our kind of first loop. And up here is our first loop. So I'm saying, imagine for a second, if you like, that the first loop is how many times we've done this loop. And then this number keeping track here is how many times we've done this loop. So now this time round, k is equal to 2. P goes back to being equal to 1 because we've started this inner loop again. Okay, and so on. So k continues to be 2 for the whole of these 5 iterations, with p incrementing each time. We still have to do it one more time. So we have our third loop, and we'll have 3, 3, 3, 3, 3. Okay, and then so k is going to be equal to 3 every time it gets run through this loop, because it doesn't change at any point. And then we're going to have, so let's get rid of this for a second. So we know that it was 2, 3, 4. So I'm going to write this down here, 2, 3, 4. So that was our second, and our third time round, it's again going to be 1, 2, 3, 4, and 5. So the first time this runs, the numbers that you get within this first slot are going to be 2, 3, 4, and it'll be 5, 6. And the second time around, it'll be different, those different numbers added to it. So the next question, the reason I've sort of drawn this all out, is how many times line 3 will be executed if this algorithm runs through once. And what that means is if the entire algorithm is allowed to run from start to finish, that is once, how many times is this line going to be repeated? And the line we're talking about is print k plus p. So if we get rid of all of this for just 1 second. I think I need a bigger eraser. Either way, okay, nearly there. So getting rid of all of this for a second. I know that my first loop is going to repeat 3 times. And within those 3 times, my inner loop is going to repeat 5 times. So essentially, I'm saying I'm going to do 3 times 5. So my entire line here, k plus p, will be executed 15 times in total. Okay. And then the last question is identify 2 basic programming constructs that have been used in this algorithm. And again, this is something that unfortunately a lot of students get the first one and then it all goes a little bit wrong. So, what are programming constructs? Now, most of the time, people correctly can identify selection and iteration. They are 2 of our programming constructs. But there's another one that is as important, if not actually more important, because if you don't get this one right, then everything goes wrong. And this one is going to be our sequencing. And what that means is, has this algorithm been written in a way that if it's not executed in the right order, it will not have the desired effect? So if I move next P and I placed up here, that would mess up the sequencing. Would it mess up my whole algorithm? Well, of course it would. That's the point of algorithms. Are meant to be written in sequence, but it is one of our programming concepts. So most people can look here and they go, oh, okay, I can see iteration, and you must write iteration or iteration, whatever I've written there. You must write iteration and not for loops. Okay, that's really important. Because for loops, although the examiner will know what you mean, the correct term is iteration. Okay. And you can't just write loops. Please don't just write loops as an answer. It won't. Exam board has already said for OCR that they don't accept that. The other one that most people then can choose is selection if it's present, which is our if else statements. And again, please don't write if else. Make sure you write selection. But as selection isn't here, I think what a lot of people tended to see, and I've marked many of these mocks, is I often get print. Okay, that isn't a construct. That is a method that we can use. It's something that you can use within, but it isn't a construct. Your 3 constructs: iteration, selection, and sequencing. So the correct answer for this one would have been iteration and sequencing. Okay. And it's only a 2-mark question. So though there's a lot of space, obviously you could have gone on and you could have explained. It's not selection, is it? It was sequencing. You could have gone on explained, but actually just writing this would have been more than enough to get you your 2 marks. Okay, so hopefully that makes a little bit of sense.